Another very important skill we need to know is whether equations of lines are parallel and perpendicular before we even graph them on the coordinate plane. Just by looking at the equation, whether it's in slope-intercept form, looks like y equals mx plus b, or in standard form, ax plus by equals c, we need to be able to figure out the slope, and then from those slopes figure out, are they parallel or perpendicular? Let's take a look together. All right. It says circle whether each pair of equations is parallel, perpendicular, or neither. Now, I have those words covered up here and I have it circled already, and I'm just going to drag and reveal, but I'll be asking you, hey, after we look at these two equations, what's the slope? And then if I see what the slopes are, how do I know? Is it parallel, perpendicular, or neither? They're just intersecting lines. In the first one, y equals x plus 3 and y equals x minus 2. We know that the slope in slope-intercept form is the number that's in front of the x. It's being multiplied by x. I don't see any number there, and that means we know that it's 1. So the slope in this first equation is just 1. When I look at the second equation, I have the exact same situation. I have y equals x minus 2. The slope is the number that's being multiplied in front of my x. I don't see any number there, which also means it's 1. Now, what's special about having the same slope is that parallel lines have the same slope. So if these both have a slope of 1, that would mean that those two equations are parallel to each other. Without even graphing them, we're going to know that they are parallel. That's pretty cool. The next one, y equals 2x plus 3. It's in slope-intercept form. Super easy to see the slope in this form. It's the number that's being multiplied by x, so I know my slope is 2. However, in the second equation, it's in standard form. And now when it's in standard form, there's two things that we could do in order to figure out the slope. One of the ways would be to rearrange this equation so it's in slope-intercept form. And so if I was to do that, I would mentally, I could write this all out, or I could mentally do it. I would say, okay, I need to get y by itself. So to get y by itself, I would need to subtract 2x. Now, if I subtract 2x, it will be a negative 2x on the right-hand side of the equation. Okay. But then I'm left with negative y. And what do we do to get rid of a negative y? Well, we'd have to divide everything by negative 1. So if I have a negative 2x over on the right and I divide it by negative 1, what's negative 2 divided by negative 1? Positive 2. That would be one way to figure out the slope when it's in standard form. The other way is to set up a kind of like little itty bitty tiny equation. The slope is that in standard form, it's negative a over b. That if I look at an equation in standard form and I set up a fraction of negative a over b, it would be negative 2, right? Because my a is 2, so negative 2 divided by b is negative 1. Negative 2 divided by negative 1 is positive 2. It's actually the same mathematical steps as what I said with rearranging. It's just in a shortened condensed form. So you do a over b and you basically just change the sign of it, and that's how you get positive 2. And if these two equations both have a slope of positive 2, parallel lines have the same slope, and so that would mean that these two equations are parallel to each other. Excellent. Next two, y equals negative x. Ooh, so there's not a 1 in front of my x this time. It's actually negative 1. And then the second equation, there's really a 1 in front of that x, and it's positive 1. Now, parallel lines have the same slope. Perpendicular lines, remember perpendicular lines you learned in 3rd grade, make perfect right angles. Okay, your 90-degree angles, your right angles. Perpendicular slopes have negative or opposite reciprocals, or they're opposite reciprocals. So the negative or opposite reciprocal of negative 1, if I took negative 1 and I flipped it, made the reciprocal, and I changed the sign, I would get positive 1. Okay, negative 1 and positive 1 are negative or opposite reciprocals of each other, which means that these two equations are perpendicular to each other. Let's take a look at the next one. Y equals 3x plus 3. That's easy when it's in slope-intercept form. Very easy to see my slope. It's positive 3. But now for the next one, x minus 3y equals 9, that's in my standard form. So I can go through and rearrange it and put it in slope-intercept form, or I can use my quick formula where m is equal to negative a over b. So now if I was to do that, what's my a value here? Well, my a value is 1, so that would be negative 1 over, what's my b value? Negative 3. What's negative 1 over negative 3? A negative divided by negative is a positive. Now 3 and 1/3, that's awesome. They're reciprocals of each other. But to be perpendicular, they have to be opposites or negative reciprocals of each other. These are both positive, which means that number one, they're not the same, so they're not parallel. They're not opposite or negative reciprocals of each other, so they're not perpendicular, which just means they're neither. It means if I was to graph those lines, eventually they would just intersect somewhere, but they're not going to be one of these special cases. Next two. 2x plus 3y equals 6. Again, in standard form. So if I use my formula of negative a over b, my slope would be negative 2 over 3, right? Negative a over b, so negative 2 over 3. And in my second one, if I follow that same thing, negative a, so negative 3 over b. Okay, so negative 3 over negative 2, a negative divided by a negative is a positive. That would give me positive 3 halves. Ooh, well, 2/3 and 3 halves are reciprocals of each other. And is one positive and one negative? Are they opposite signs of each other? They are. So that means that these two equations would be perpendicular because the slopes are negative or opposite. You can call them either way, reciprocals of each other. Awesome. Next one, y equals 2/5 x plus 3. Slope there, easy. 2/5, no big deal, right? Slope-intercept form is so easy to see the slope. Next one is in standard form. So if I set up my equation, my little quick equation of negative a over b, it would be negative 2 over negative 5. A negative divided by a negative is a positive, and so that would also be a positive 2/5 slope. Parallel lines have the same slope, so that would mean that those two lines would be parallel to each other. Last two, 4x plus y equals negative 6. Again, in standard form, I can use my formula of negative a over b. So this would be negative 4 over 1. Negative 4 over 1 is just negative 4. The second equation in slope-intercept form, I can easily see has a slope of negative 4. What do parallel lines have? They have the same slope, and so I know that these are parallel to each other. Last one, y equals 5x plus 3. I can tell my slope is a positive 5. In the second one, x plus 4y equals 8, it's in standard form. So my formula is negative a over b, so negative 1 over 4. And those slopes are not the same. They're not negative reciprocals to each other, so they're neither. They're just going to be intersecting lines. I hope this video was helpful. Thank you so much for watching. Bye.